Welcome to a lesson with Dr. Powell. Let's talk about the standard statement of the mean value theorem. It starts out by saying if f prime of x exists on the interval, and that's all we require. Notice in the last slide or last video, we said that that we required that f prime of x was continuous on this open interval. Well, all we need is that it exists. And part of that has to do with we're taking like a rise over run. Here, I'm introducing like a z and an x and a y. Well, think of x and y as just simply being two x values, if you will, even though I used a y, but two x values, and they're getting really close together, and then you're plugging them into f. I mean, this is really as x approaches y, or they kind of approach each other, this really is heading toward a derivative of f evaluated at some point. Now, if you thought of x, y as being points in the coordinate plane, and the value of this being actually like an altitude above that point, x, y, so kind of going up into the air here, kind of above this surface, maybe like, like hilly up here, whatever, you're actually going to get a nice smooth surface, but you're going to have things not defined. There's going to be a rift right where x is equal to y. But the beautiful thing about that rift, though, is because this is so nice and continuous, even in two variables away from it, it forms a nice rift pattern right up to it, where really this is there's just a line here, just kind of a whole edge, but it can be completed just by filling in, since these limits exist, since the derivative exists. Since it's a nice rift that fills in, actually, that rift filling in is really the function filling in, the derivative function filling in, which is nice and smooth and continuous. Kind of an interesting fact. All you need is that the derivative to exist, really, on that interval, and you'll get that it's continuous as well. So suppose, because it's defined by limit type operations anyway, which kind of belie continuity itself. So really, this is all we need, just that the derivative exists. What does the derivative exist mean? It means that tangent lines exist, basically at every point. All we need is that tangent lines exist at every point in the open interval. So, instance, you don't want something like this because you don't have a tangent line existing at that point. Okay, so that's really what we need there. We just need that f prime exists. That's all we need there. Now, we also require that f of x is continuous on this interval. Now, what does that do? That ensures that on the interval we don't have something like a hole there, or something like, something funny like this going on, okay, at a and b, because we want f of b minus f of a to really be the displacement of the function f, so that it's the integral of its derivative really gives us what we want in the average calculation. So so we do require that it must be continuous. All right. So we require continuity, and we require that f prime exists. That's enough. So assuming that, then there exists a c somewhere in the interval such that the slope of the tangent line is going to be equal to the slope of the secant line. So pretty much, in some sense, we just have that the mean value theorem is that the slope of the tangent line somewhere in the interval is equal to the slope of the secant line in that interval. The next video, we'll look at more pictures and examples and explanations of this idea. Thanks for watching.